When you start looking at problems 15, 16, 17, 18, and 19, you should notice there's absolute values in them. And looking at the video from 8, 9, and 10, there's two things you have to set up and solve for absolute values anytime you do them. So something like x plus 1 greater than 2. Well, this means I want a whole bunch of numbers to be absolute value to be bigger than 2. So it's a whole bunch of stuff going this way and a whole bunch of stuff going this way. That's what it would be like this if it was just x. But now with the plus 1, that's going to change from where I start from, and when I make bigger ones and from when I go from and make smaller ones, and I'll show you that. So I want all the numbers in the absolute values to be greater than 2. Now when I make my second one, like I said, I keep the absolute value, but I switch the sign because I'm going to flip to the other side of the number line. So I do less than negative 2. Minus 1 minus 1, x is greater than 1, and minus 1, x is less than negative 3. So if I were to draw a number line of this, I have positive 1 here, open circle, numbers are bigger than 1, that way. Negative 3, open circle, numbers are less than negative 3, that way. So to write this in interval notation, this is an OR statement, just like the video I showed you for number 14. So negative infinity, I do this graph as one in notation. So negative infinity to negative 3. Union, so joined with, the solution set of positive 1 to positive infinity. This entire thing would be your answer for that. Now, moving on to something like number 16. You would set up the same way. If I had a problem like 16, I would 2 minus 4x less than 8. I would set up two problems. 2 minus 4x less than 8. 2 minus 4x. Now remember, I want numbers to be less than 8 on one side, but I also want them to work on the flip of the number line, so I'm going to flip this around and make that negative 8. Minus 2 minus 2, negative 4x is less than 6. Divide by negative 4 is the only way I can divide by. X is less than negative 1.5. This one, subtract 2, get negative 4x is greater than negative 10. Divide by negative and negative. X is great. Oh, one thing I didn't catch back here. I divided by a negative here. That means I need to flip my sign around. Sorry about that. On this one, this is when I caught it. I'm dividing by a negative, so I need to flip this sign around. So let's graphically get it on a number line, what it looks like. Okay, numbers are bigger than negative 1.5. Open circle goes this way. Here's 2.5. Open circle goes this way. Well, this is an AND statement. If they're going like this, and especially if it starts off like this, it's an AND statement, it's going to be one answer. It's not going to have a union in it. So it's not going to have this in it. Sorry, the click is 0. It's not going to have that in it. So the answer would just be between this and this. So it'll be negative 1.5 to 2.5. Parenthesis on both because neither of them are underlined. When you get down to like 17 and 18, if you start off with this symbol, that means an OR statement. It can be an either or both, so you need to consider both of them when you're looking at the solution. When you start off like something like this, it means an AND statement. So you need to consider what's in both this and this answers where they overlap. Problems like 17 and 18 are very similar to a problem like you did in number 10. You need to isolate the absolute value first. So So do like this example, like 17 and 18. So something similar to that. If you have absolute value of 2x plus 4, absolute value minus 5 greater than or equal to 13. Before I start making two problems, I need to make sure this is by itself, because the absolute value is what determines that you have two solutions. So if you add 5 to both sides, absolute value 2x plus 4 greater than or equal to 18. Now since I have this, I need to figure out the numbers that are going to give me bigger than or equal to positive 18, so what solutions for the variable, and then the ones that are give me less than or equal to negative 18, because when I plug a negative 19 in here and absolute value it will still be bigger than 18. So I want to set them up where exactly how this looks, and then set this up with flipping the inequality and the opposite of that number, so it's on opposite sides of the number line. Subtract 4 from both sides, you get 14, divide by 2, 7. Subtract 4 from both sides, you get less than or equal to negative 22, divide by 2, x is less than negative 11. So my number line would look like, here's 7, here's negative 11. This way, numbers are bigger than it. Got this one, numbers are smaller than it. So I have this solution to negative 11 joined with, or 7 to positive infinity. Hope this helps. Good luck on the homework. I hope you find it a little bit easier than last week's.